Okay guys, let's get started here. So my name is Ashutosh Dash. I work for HPE as a product manager at the Aruba Wireless LAN business unit. So before I start, I know the audience is pretty thin, but I'm going to ask how many of you use Skype for Business? Good to know that. So what I'm going to show today is if there is an issue going on with your Skype for Business call, if let's say you make the call over the wireless network, where the problem might be, right? It might be with the wireless network, it might be with the wired network, it might be with the endpoint device. So how do you effectively troubleshoot if somebody is complaining? That's what I'm going to show you guys some of the capability what Microsoft has developed and we have integrated in our product. Let's get started here. So I'll go over some of the UC challenges, different network components or segments, what are the different challenges. Then I will talk about Aruba's campus architecture, primarily the headquarters, the branch deployments, typical Skype for Business deployments, and then how do we intercept the Skype for Business traffic and prioritize the voice, video, desktop sharing, file transfer, and different kind of other Skype for Business traffic. Talk about some of the multi-tenant, multi-site Skype for Business deployments, and how you can resolve some of those issues with roaming and stuff like that. And finally, I will have a demo. This is the single pane of glass I'm talking about. I'm going to show you how you can troubleshoot your network better. So let's say the first thing is here in this example I have the wireless network and the wired network piece and the Skype for Business server as well, right? So if you look at the wireless network itself, the first thing comes with the endpoint, end device. The end device can be a smartphone, it can be a tablet, it can be a laptop, it can have different operating systems and things like that. So a smartphone is a slow device. It can send data at a slower rate. A laptop is a faster device, right? So when they transmit data over the air, slow device will take more time. Faster device will take will transmit the data faster, and some of these devices are capable of applying the quality of service on the data when they send it out. For example, Windows devices, you can apply the class of service when you send the data out, but some other devices they cannot. When you apply the quality of service, it takes less time over the wireless. The second component is the access point itself. There can be RF, like we are connected through Wi-Fi here, is a shared medium. Many devices are there. There can be Wi-Fi and non-Wi-Fi interference. One example of non-Wi-Fi interference is the microwave, right, or some other devices. Then there might be channel congestion. One access point can handle so many calls or so many devices. So there might be a problem there, right? So the third component here is the wireless LAN controller. So Skype for Business, it's an encrypted traffic. Do you have a stateful firewall built in to your controller or to your switch to look into these encrypted packets by doing deep packet inspection to figure out whether it is a Skype for Business voice, video, call, or something else, right? So once you figure that out, then you can apply the right class of service on those calls. It's not enough you do things right on the wireless side, right? Once it goes to the wired network, we need to make sure the quality of service is still honored in the wired side as well. For example, if you have MPLS network, once it goes to the MPLS side, the MPLS provider should make sure that quality of service is maintained there as well, right? Finally, again, there is some overhead with the routing and switching on the wired side as well. The Skype for Business server itself, that the front-end server has some capacity to handle how many simultaneous calls. The infrastructure, Skype for Business infrastructure, has limitation of giving you the visibility about the end-to-end call quality metrics in terms of packet loss, jitter, and device type, and so forth, right? So there might be some issue there as well. So let's take a quick look, what is Aruba as such. So the first big box what we are seeing is your headquarters. We need to make sure your employee traffic gets prioritized. We need to make sure if you're carrying multiple devices, the employee are carrying multiple devices, we need to find out this is the device carried by the employee and the employee is trying to make the Skype for Business call. We need to intercept and make sure we prioritize those calls. Campus is not enough, right? We have the branch controller, let's say the branch of a bank or a dentist office, a lawyer's office, that kind of deployment. That is something called instant cluster there. If you have a higher ed customer, if you have satellite offices, right, we need to make sure the Skype for Business calls are prioritized there as well. And finally, the remote access point, the home-based access point, right? And there we need to make sure you have a good experience with your Skype for Business call. So this kind of addresses most of the deployments. So how do you do it on the Skype for Business over Aruba, right? So the entire architecture what I have drawn here is the Skype for Business architecture, right? So the front-end server is here, the quality of experience server is right there, Active Directory, the Extend server. So we integrate, our wireless controller integrates with the front-end server and gets information about the call detail records, who is calling, what time they are calling, are they calling PSTN calls, are they calling Wi-Fi to Wi-Fi calls and so forth, right? Not only that, they also extract information about the call quality metrics in terms of mean opinion score, in terms of packet loss, jitter and delay end to end, which gives you wireless segment, wired segment and the devices. So other piece is, what I was talking in the previous slide, it was completely related to the wireless LAN network, right? Let's say we have wired clients connected to the switches and stuff, right? So in that case, how do you do it? So we have something called network optimizer. We call it as SDN controller, and that integrates with the Microsoft front-end server. It extracts the information, who is calling, what type of call it is, and then through OpenFlow, it programs the network with those, the QoS, it programs the quality of service. With voice call, it will have DHCP46 and things like that, right? So it also integrates seamlessly with the wireless LAN controller. So in terms of classification method, we have two methods. One is the heuristics-based method. Because we have a stateful firewall built in, we can do deep packet inspection, find out whether it is voice or video call, and we can apply the right class of service. The second method is called the SDN API. This is the one Microsoft has developed, and we have integrated with that particular API. So with this API, it gives you not only visibility into voice and video call, it also gives you visibility into desktop sharing and file transfer type of calls as well. Not only that, it gives you information about the end-to-end call metrics. It gives you information about the device-specific information, what kind of speaker I'm using, what kind of microphone I'm using, what kind of operating system I'm running on, like all that information it gives you. So SDN API is very powerful, and I think you guys might have heard about many other vendors talking about this API, and through this API is the interface we get all that information from the Skype for Business server side. So real quick, how this happens. Heuristics is the mechanism, deep packet inspection, stateful firewall, and it is ideal for the Office 365 deployment, the Skype for Business online deployment, because the Microsoft SDN API is not supported for Office 365. They have plans, but they haven't supported. If you have that deployment, you need to use heuristics. The second method is the SDN API, which is ideal for on-prem and hosted deployment, and it gives you a lot more visibility and troubleshooting information. And all this troubleshooting and visibility information is aggregated on a network management platform called Airwave, which I'm going to demo in a bit. So as you see here, two different kind of methods. With SDN API method is very powerful. It gives you a lot more visibility, a lot more troubleshooting information. It gives you the correlation between the wireless statistics, the wired statistics, and so forth, right? So if you have option of doing SDN API, please do so. Only thing with SDN API is you need to touch your Skype business network, because you need to configure that network to talk to our network controller or whoever is deploying that, right? So, but with heuristics, you don't have to touch anything. So some of the deployment use cases here, multi-site and multi-tenant kind of a deployment. So if you're deploying, different geography, then if you're using SDN API, only recommendation is you make sure your SDN manager cluster is local to that particular region. And if you have, Office 365 and SDN, the on-prem and hosted deployment, then you don't have to do much. You just have to enable, SDN API, and heuristics is enabled by default. With SDN API, it will take care of your on-prem and hosted deployment, and heuristics will take care of the Office 365 deployment. Now is the time for demo. So let's say there's an issue with the Skype business call, right? The first thing, as an administrator, you need to find out, can I go back and look at the data, right? So first thing is historical data. So you can set your historical data, okay? With our solution, you can go back to 1 month. 1 month of data you can view. The second thing we need to find out, what is the call trend over a period of time, right? Where the maximum call happened. Then you might want to know what is the call quality, where the poor call quality, what time frame it happened, what time of the day, and things like that, right? And again, you need to have visibility into different kind of devices also. If you have a lot of Mac devices, maybe the Skype business might not work very well because the API is not very well integrated with that kind of devices. So then we have the quality correlation. If there is a problem going on, for example, this shows the wireless health of the client. This shows the end-to-end call quality. For example, if the dot is here, it's a poor call quality call, and this is because of your wireless health of that device is bad. It's only 10%, right? But if the dot is here, that means the wireless health is good, the wireless network is good, but still we are having a poor call quality. That indicates it might be with the wired network or with the device itself. So if somebody is complaining, you can look for that particular client, then you can see how the client is connected over the network. So that's where you are asking about the Cisco switch, right? So you can find out what switch they're using. For example, here they're using an HP switch, and it will tell you the possible issues. Let's say you are applying the quality of service here, but the Cisco switch is dropping the quality of service. It will tell you right here, and you can click on that particular switch. It will tell you what are the problems might be. If there is a queue overflow, there is a delay happening, or there is a quality of services getting dropped, all that information will get visible here. And I'll show you an example here. So let's say I'm clicking on the client, right? It tells me, hey, device type is so and so. The signal to noise ratio for the device is pretty good. The RF health is good. The speaker glitch rate and microphone glitch rate looks pretty good, right? Microsoft recommendations is it has to be 1 per every 5 minutes. So it is working perfectly fine. So one great thing we are seeing here is the transmission retry. So that means on the wireless side there is some retry happening because of the channel congestion or so forth. We can further troubleshoot and find out what's going on there, right? You can click on the access point and also find out more information about the channel utilization, channel interference, and so forth. And here it gives you some information about a lot of information. It gives you what type of calls it is, but what is important to you guys is the UCC score, which is it tells you what is the Wi-Fi health of that particular particular call leg, right? So if it is above 70, it's a good call. It's an excellent call. If it is 30 to 70, it's a fair call. Below 30, it's poor call. So this is the wireless side. MOS score is the mean opinion score. It's an old standard. That tells you the end-to-end call quality. Anything above 3.65 or so, it's a good, it's a good call quality. It is, though it is tied to the codec you are using. And the quality of service correction, like for example, if the client is not able to apply the quality of service when it sends the packets out, or the wired network is changing the quality of service. Once it comes to our controller or our switch, are we able to intercept and fix that quality of service, right? For example, your voice network, let's say for voice traffic, you use DHCP 46 for voice. So when it comes to us, let's say DHCP is marked as 0. Once it comes to us, are we able to intercept and apply that DHCP 46 when we send the packet out? So that is what the QoS correction is. So this is what I was talking about, in terms of the single pane of glass, right? You have visibility into end-to-end call quality metrics in terms of delay, jitter, packet loss, the overall, call quality metrics. That's for end-to-end. We also have the wireless LAN call quality metrics. Not only that, we also have visibility into the device information as well, microphone and speaker information as well. So what it, again, we also have other stuff there. So what it tells you right here is where the problem might be. And this interface we have developed based on our customer feedback. So in the endpoint device, you can see not only it gives you, the operating system information, it also gives you what kind of device driver they're using. You can go back and check, are they using the latest driver or not? So is this useful? Is this like in your daily life, if somebody is complaining, if you look up this data, will it help you guys to troubleshoot? Okay, good. So finally, one of the complaints customer has is, hey, the overall call quality looks very good, right? If you are in a conference call and 30 seconds of that conference call is bad, so how do you troubleshoot? How do you find out the 30 seconds of the call quality is bad, right? So we do minute by minute analysis and find out when that bad call quality happened. And that period of time, you can see different network segments to find out where there is maximum number of packet loss, where there is maximum number of delay. So we have developed this information through that SDN API, what Microsoft has developed, giving this data to us. So do you think this is helpful to you guys? Cool, thank you. Any questions? Yes, we have some tools, we can chart those numbers as well. So that's all I have for you guys. Thank you very much for attending.